So a geometric series has a first term A and a common ratio R, where R is less than R is a negative value. Okay, the sum to infinity series is 18. So basically, just understand that more R is less than 1. But because R is less than 0, so meaning to say, because R is minus 1, R between negative 1 and 1, right? You take this and this, merge them together. What you want to find is just R less than 0 lah. So this is what you want. Sum to infinity is 18, and its third term is 8 over 3. So you can see that actually it's not too bad lah. The way they phrase the question is quite still manageable. Third term is U3, which is AR square. Okay, so we're just gonna proceed to do that. Sum to infinity is 18. 18 is equal to A, 1 minus R. Then U3, which is like 8 over 3, is A, R square. Okay, so I don't think it's hard to see. Basically, what we need is to make A the subject and then just substitute in the second one. Then you can just show this really. So just show, this is last year's. This is 2024 paper 105. You see that it's quite simple and it's 3 marks. Okay, so this one don't give away. So just key in calculator, if you were to just reduce this, right, it will be 4 over 27. Okay, so just that will be 4 equals to 27 R minus R cubed. Shown. Part B shouldn't be an issue, right? Just solve it lah. You already solved, so just solve it. From GC, just solve for R. It's only 1 mark. It's only 1 mark, right? So you just solve from GC. What's the R? Here, go to app. Then you go simultaneous equation, poly root finder, degree of 3. Then you just graph it lah. So this is 27 minus 27, and then put this as 4. Solve it. Okay, get this answer here. Keying wrongly, so it's R square 2 is negative 27. There you go. So reject as R is less than 0. So A will be, there you go, 24, I think. Okay. So C, we need to discuss lah. So given that N is a UN term, then you need the summation of UR K plus 1 to infinity. Then this is 1 to K lah. So how would you do it? Now I think the first thing is to understand that this guy here is sum to infinity, K plus 1 to sum to infinity lah. So if you draw on a number line, you'll see this. So this is what's going on. You want UK plus 1 to infinity, which is this guy here. Okay. So this is R equals to K plus 1 to infinity UR. Okay. But what you have is sum to infinity to, so you have this guy, right? This guy here. This is just Sn. U1 to UK is just SK, right? You sum to the K term. Okay. So essentially, this entire thing here, if you sum from here to here, this entire thing, this is what? Sum to infinity. Okay. So change of base. When you think about change of base, you have to understand that K plus 1 to infinity, okay, will be S to infinity minus all of this SK. Okay. From the number line, you can see it. So just understand that. Okay. That's all. So if I were to do it, rewrite this thing. This is SK lah. This guy is SK. This 1 to K is just SK. We already have sum to infinity, so it's 80 SK equals to SK. So this is 81 SK. 80 S infinity. What do we want to find? Find the value of K. Okay. Sum to the K term with A, 1 minus RK over 1 minus K lah. Or 1 minus R. So they just key in calculator. I mean, just apply formula. We already found previously what's A, right? A is 24, R is negative 1/3. Then you just solve for the K lah. Basically, you have to see this is 81 is 3 to the power 4. Okay, you can rewrite this as minus 1/3 to the power 4, so you can see that K equals to 4. But sometimes we want to log both sides, right? But when you log both sides, you can't really log a negative number. So when you put this, you just make sure you put the modulus. Then later you check if you get the, because you just put this modulus K is log 1/3. Okay, just mod it. Then later you check if we satisfy the equation above. Okay, but actually you can just understand that this guy is 1/3 to the power 4, which is 1/3 to the power, because degree of power 4 will just make it positive. Okay, so but anyway, you just do this. K is equals to ln 1 over 81 over ln 81 1 over 1 over 3. K is 4.